Yeah. Okay.
So that
Well, you're going to do that. Yeah. We, you want us to mute? Do you want me to mute mine?
Yeah.
Okay.
Do you want me to mute mine too?
No, but you guys can kind of talk with yourself. Don't be able to hear, people off the stream be able to hear some chatter and stuff. But not specific. So, and you can set that on the table next to you, so it's easier.
So you want it muted or not?
I think you might want to put your microphone back on. So you're ready. So you don't, then let's not worry about it.
Good morning. It's 8 o'clock, so we'll go ahead and get started. My name is Vicki Fraser. I'm the chairman of the Department of Medicine at Washington University School of Medicine, and it's a privilege to welcome you here to this morning's Dr. Gerald Medoff Visiting Professor Lectureship, in which we have Dr. Tony Fauci joining us. So just to start off, I'd like to give some recognition to Dr. Gerald Medoff, for whom this professorship is named. Jerry, who is a beloved and esteemed former faculty member and division chief at Washington University School of Medicine, was born in Brooklyn, New York, and is well known to have been an incredibly hard worker who actually started working to help support his family when he was a child, delivering mail and telegrams and working as a merchant marine even. He went to college at Columbia College in New York and then came to Washington University School of Medicine for his medical degree, did his medicine residency at the New England Medical Center and Boston City Hospital, and his ID clinical and research fellowship at the Massachusetts General Hospital in Boston. He then joined the faculty at MGH and Harvard and Boston Children's Hospital, attending both in pediatrics and adult infectious disease. He was then recruited back to Washington University as the first infectious disease faculty member here and soon became the division chief of infectious disease. Jerry was a distinguished physician scientist whose basic science research focused on the pathogenesis of Candida and histoplasmosis. He was key to developing the fundamental insights into the mechanisms of some of the antifungal agents at the time, amphotericin and 5-FC. He was one of the founding leaders of the mycosis study group, and he established the first infectious disease training grant here at in infectious disease, which is now almost 50 years running. He also was the infectious disease division director here for more than 20 years. He was actively engaged in fostering and developing the first Washington University AIDS clinical trials unit here. He established the HIV clinic here. He was an incredible advocate for patients with HIV and AIDS very early in the epidemic. He also provided extraordinary leadership in a number of areas of infectious disease, including antimicrobial stewardship, infection prevention, pharmacy and therapeutics, and also quality and safety. He was honored by being a member of ASCI, the AAAS, he received the IDSA Walt Stamm Mentor Award and the WashU Distinguished Educator Award, the Second Century Award, and the Neville Grant Award for being an outstanding clinician. Jerry is known to everybody for having an exceptional eye for talent and a passion for developing people's careers. He recruited outstanding faculty and fellows and scientists into the division and grew the division into one of the top divisions in the country. He mentored and developed faculty in a number of different areas, including basic science, clinical research, parasitology, virology, microbial pathogenesis, HIV, sexually transmitted infections, hospital epi, safety, quality, and informatics. He gave up his basic science lab while he was still well-funded and incredibly successful to focus on improving clinical medicine here and also clinical research in infectious disease. He became the vice chair for clinical affairs for medicine. He was the associate chief medical officer for BJH and also an outstanding and compassionate clinician and educator. He had a tremendous sense of humor, was a terrific storyteller, and a baseball aficionado. He was a devoted husband, father, and grandfather to his wife, Judy, who's here with us today, his sons, Ben and Nate, and their wives, Alicia and Sherry, and his grandkids, Julia, Alex, Jonah, and Jacob. So it's a real pleasure to have the Medoff family here with us today and also to recognize Jerry's extraordinary contributions to the Department of Medicine, to Washington University, and to the Infectious Disease Division. So now it's my privilege to introduce Dr. Bill Powderly, who's going to introduce our speaker this morning. Dr. Powderly is the J. William Campbell Professor of Medicine and Infectious Disease, the co-director of the Division of Infectious Disease, and also the Larry and Carol Shapiro Distinguished Professor and head of the Institute of Public Health, and he's also the PI of our CTSA. So Bill, thank you.
Thank you, Vicki. It's rare that in medical grand rounds one introduces somebody nice saying they don't need an introduction. But let me say a few brief words about Dr. Fauci. Like Jerry, Tony is a native of Brooklyn and also a baseball aficionado, although he supports the wrong team. He graduated from Cornell Medical School, where he also had his residency in internal medicine. In 1968, joined the National Institutes of Allergy and Infectious Diseases in the Laboratory of Clinical Investigation, where he had a distinguished career as a physician scientist and investigator, making seminal observations and insights into polyarteritis nodosa, Wegener's granulomatosis, and other angioitis. In 1984, he became director of NIAID at a time when we were just at the beginning of another pandemic, that of HIV/AIDS. And Tony has led the NIH's response scientifically in basic science and clinical investigation to multiple infectious diseases. Under his oversight, the NIH has fundamentally led investigations that have changed the nature of HIV to a treatable disease with the development of effective therapy, effective prevention, and incredible insights in immunology and basic science. He also has been an incredible advocate. He was one of the first people to advocate the involvement of patients in scientific inquiry at every level, and was a guiding light towards in the creation of PEPFAR, which has been this country's response to the global pandemic and has allowed many people across the world access antiretroviral therapy. He has advised 6 presidents on emerging infectious diseases, and he has done that at the same time as being an active clinician, looking after patients at the clinical center, an active clinical investigator, and continuing to run an incredibly productive laboratory, and an advocate for science-based public health. It is fitting that he is still in charge of the NIH at the time of the latest pandemic, and we are delighted to welcome him here to share some insights. We're going to ask Dr. Fauci to make some opening remarks about the state of the nation in terms of the current pandemic and what he sees as the most important issues to address at the moment. And then we're going to have a series of question and answers based on questions that we have generated from our fellows and residents in internal medicine. So with that, welcome, Dr. Fauci.
Thank you very much, Bill. It's a real pleasure and an honor to be here. Thank you, Vicki, for your introduction, and greetings to the family of Jerry Medoff. It really is a very special for me to be here with you to give this Jerry Medoff lecture, because it's really an expression on my part of the extraordinary respect and admiration that I've had for a very long time for Jerry, and the extraordinary accomplishments that he's made in the field of clinical infectious diseases. So I say sincerely, it really is an honor to be here and to participate in this grand rounds that is named after Jerry. I want to make just a couple of comments that Bill said, and then I will get into the questions, because they generally are more interesting than anything didactic. But I think in order to just put it into some perspective, we are in a very, very difficult situation right now. If you look at the trajectory of the curves of the surges that we've seen, as you know, things in earnest began to be really serious, or at least recognized to be serious, as we got to the end of January, the beginning of February of 2020. So we really are just coming to the end of the first year of what is now historically the worst pandemic of an outbreak of a respiratory-borne illness in 102 years since the infamous 1918 pandemic. The numbers are really stunning when you look at them. One of the issues of having been really gripped by this now for 11 months to almost a year is that the numbers are so extraordinary that we've become numbed to them. As of yesterday, there are 360,000 deaths. We have had a situation where we now are averaging between 200 and 300,000 new infections per day, and between 2 and 3,000 deaths per day. Every day is a new record for the number of people hospitalized with COVID-19, 138,000 as of yesterday. There are some regions of the country that are really getting to the point of what we consider the unimaginable, where you'll actually have to triage and determine who is going to get taken care of and who is not. I refer specifically to the very difficult situation that's going on in California, particularly in LA County, where they are running out of beds and they have an exhausted staff working almost 24 hours a day. This is truly an extraordinary situation. We expect it to get a bit worse as we get into the middle and end weeks of January, because of the fact that after every single event that would bring people together in travel, be it the 4th of July, Memorial Day, Labor Day, Halloween, Thanksgiving, and now the Christmas holidays, there's always a surge as people travel and congregate in social settings. So the numbers that I gave you are very, very difficult to comprehend. They are extraordinary, and yet things could actually get a bit worse. On the other side of the coin, there is light at the end of the tunnel with regard to vaccinations. As you know, another record, we've made records, very, very difficult records with regard to illness and death, but we also have a record with regard to vaccine accomplishments. You might recall that the sequence of the virus was put on a public database on January the 9th. And in less than a year, in 11 months, we went from a sequence to actually having vaccines in the arms of individuals, vaccines that are not just any vaccine, but a vaccine that's 94 to 95% efficacious with a very good safety record. The challenge now, and we can get into that in the questions, is to get the vaccine out and implemented in an efficient way so that we can get the overwhelming majority of our population vaccinated within a several month period, which will be the real gateway to the end of this terrible outbreak and would get us back to normal. So there's very disturbing news and there's some promising news. So Bill, let me stop there as just an introduction. And then I know we have a list of questions that I think would touch on almost every aspect of this, and I'd be happy to try and answer them.
Dr. Fauci, thanks so much for that. So the first question is, throughout the pandemic, evolving knowledge has really led to recommendations that changed based on new data. And that, in some cases, had led to some loss of public trust or misunderstandings. So for the remainder of the pandemic and future major public health threats, how can we better prepare the general public for public health measures and interventions?
Well, that's a great question. And there has actually been evolution of recommendations and policies that were really based on the evolving science, which is understandable that the general public doesn't quite get it because they think science at any given time is absolute, whereas science is really a reflection of the evolving data and evidence that we get. So in the beginning of the outbreak, you might recall when the information we were getting from China was that this was mostly a zoonotic that had jumped from an animal to a human in the context of a wet market with very little transmissibility from human to human. Then we found out it did transmit from human to human. Then we found out that that transmission was very, very efficient. And then we found out, much to our dismay, but it wasn't until the end of February, the beginning of March, when it became clear that transmission, 40 to 45% of it was from an asymptomatic person to someone who was uninfected. That changed everything with regard to our ability or not to contact trace, the role of masks, which has changed. For us in the beginning, it was felt that there was such a shortage of masks that we didn't want to take it away from the people who were healthcare providers. And we were completely unaware that there was transmission from asymptomatic individuals. When it became clear that there was not a shortage of masks and that in fact it could be transmitted, and that when you looked at the meta-analysis of the data, that masks work, even cloth masks that were not the typical surgical masks and not the typical N95. So things changed, and with that was, I believe, an impression on the part of some people who didn't understand how science evolves, and you've got to deal with the data as you know it at a given time, that there was a mistrust in science and mixed message. This was compounded by the fact that there was mixed messaging coming from Washington, because the public health measures took on an air of political ideology, something we've never had before in my experience in public health, where wearing or not of a mask would be a statement of where you stand politically. That is so, I would say, besides being unacceptable, that is so destructive to the trust that's needed when you want to mobilize a country. So the best thing now, looking forward, is to realize that we don't know everything, and we will continue to learn as we go on. And I think the thing that's right up in everybody's mind right now is what is going to be the impact of these mutations that have been reported in the UK and the Republic of South Africa, and what impact is that? We know now that it does have an impact on transmissibility. What impact is it going to have on monoclonal antibodies? And will it, right now it doesn't look like it will, but will it have an impact on the efficacy of vaccines? And I think the general public, in order to trust us as scientists, have to realize that we don't know everything we need to know at any given moment, that it will evolve and we'd have to make adjustments as the science gives us data and evidence.
Thank you.
So Tony, as you look back, the HIV epidemic and COVID have had similarities in terms of the intersection of politics and misinformation that has often interfered with how we tackle the disease. So what are the similarities that you've seen, and what are the differences, and how can we move forward?
Bill, I think there are more differences than similarities, but you are correct that there are similarities. The similarities, I think, are obvious. A brand new infection that started off as a zoonotic, jumped species, and then spread throughout the population. That is clearly a similarity. Somewhat similar, but actually fundamentally different, is the political aspect of it. The leadership in the beginning of HIV in the early 80s was a lack of using the bully pulpit of the leadership of the government, including the President of the United States, Ronald Reagan, who didn't do anything proactively to make things worse, but by omission didn't use the bully pulpit of the presidency. So there wasn't political disagreement. There was an omission of the use of the office to bring attention to this, as opposed to just sort of letting it go, because it was very insidious. And then we get to the now multiple differences. With HIV, as I'm sure you remember, it was kind of below the radar screen. We had a very distorted view of the impact until we got a test to do surveillance, because we thought that the only people who were infected were people who were critically ill. So the first patients that I saw in 1981 were critically ill and came to our attention because they were critically ill. Little did we realize that for every one of those, there was many, many, many fold who were infected and not yet ill. In contrast, what we're dealing with now is an absolutely explosive outbreak that in a very truncated period of time has essentially immobilized the planet. Whereas with HIV, it was stigma as opposed to political divisiveness. We try to get rid of the stigma. We've done better and better as the decades have gone by, but there was never political divisiveness that hindered what we were doing. It was attitudinal and stigma. Whereas now, as I mentioned in my opening comments, we have something that I've never seen before in public health that makes it very different from HIV, is that public health has been immersed in a divisive society, which has made it very, very difficult to have a uniform response. I mean, I might give an example of something that I believe you all there are aware of, that there are regions of the country where hospitals are filled with people in intensive care units who are dying, and the people in the community still feel it's fake news, it's a hoax, and it's a conspiracy. That to me is unimaginable that that is going on in the United States. You know, something almost as unimaginable as what happened last night in my town here of Washington, D.C. Something that you say, how could this possibly be going on? And that's a big difference between what went on with HIV and what was going on right now with COVID-19.
Thank you. So what was the most unexpected obstacle of the pandemic, and how will this change our pandemic guidebook going forward?
Well, there were a couple of them, Vicki. One was the one that I just mentioned. The most unexpected obstacle would be that we would not have a uniformity of agreement of what needs to be done in a public health response. When you're dealing with other outbreaks, not everybody complies with things, but at least you agree what you need to do to either prevent or treat. Whereas here, there were fundamental disagreements about things like mask wearing, congregate settings, people who don't believe that this is something that's serious. The other thing that really confounded it, that was so different from any other infectious disease that we've had to face, and that is, I have never seen any infectious disease where the variability of going from 40 to 45% of people who have absolutely no symptoms. If you look at the people who have symptoms, 80% have mild to moderate, and about 20 to 25% have severe, which brings them to a hospital, intensive care, with a high risk of death. You would think that an infectious disease that has already killed 360,000 Americans would make almost everybody that it infects at least a little bit sick, but it isn't. And I think that's gets into the way of messaging. How do you get a young person who knows that statistically, if they get infected, they may get no symptoms, and if they get symptoms, they're very mild? How do you get that person to abide by public health measures that are very restrictive to their lifestyle? And that's the reason why even in the midst of an outbreak, you still see people congregating at bars without masks in different parts of the country. That has been a big surprise and unexpected that we would have to deal with that.
Tony, you talked about the incredible scientific advance with the vaccines. The technology that we're using for the 2 approved vaccines is a new technology, and some, including physicians in this audience, have to counsel patients about safety issues, which we obviously don't know completely yet. How would you advise young physicians, primary care physicians, in advising patients in terms of the risk and benefit of the vaccine right now, and particularly the mRNA vaccines?
Yeah, well, that's a very relevant question, Bill, that we get asked all the time. And as scientists, we should say, follow the science. Look at the data and look at the evidence. So you have, yes, a brand new platform, an mRNA, and you take a look at the testing that's been done with this particular vaccine, excuse me. So the two vaccines that have now been given an emergency use authorization are the Pfizer and the Moderna product. The clinical trial with Moderna involved 30,000 individuals. The clinical trial for the Pfizer involved 44,000 individuals. The safety record has been really quite good, comparable to any other safety record. As we've gone out and given it to now over 4 million individuals, there have been 21 documented cases of severe allergic reactions, which brings it to a incidence of about 1 every million. So there'll be 1 in a million, almost invariably in people who have a history of severe allergic reactions. So yes, there is an adverse event, but it is easily manageable. That's the first thing. The second thing is that people say, well, what about long-term effects? If you look at the history of vaccinology and you find out when the so-called long-term, which means one that isn't just 24 to 72 hours following the vaccination, the overwhelming majority, more than 90%, occur between 30 and 45 days following the dose. And that is the reason why, baked into the approval process of an EUA, that the FDA does not grant an EUA until 60 days have gone by from the time that 1/2 of the people in the trial have gotten their last dose. So before you even get to an EUA, you have to go well beyond where almost all of the so-called long-term effects occur. So although in biology, I don't need to tell this audience that, you can never 100% say something is safe, but it would be extraordinarily unusual if you see any unanticipated long-term effects. So I think when we talk to our patients and the people who are going to be considering vaccination, we should present them with the facts as they exist, and that's what the facts are.
So Dr. Fauci, as healthcare workers and community members start to receive COVID vaccines, how should we counsel our patients regarding the mitigation measures of masking and social distancing going forward with vaccine as part of our armamentarium?
Yeah, we should not pull back from mitigation methods until the level of virus circulating in the community is at such a low level that it is no longer a risk. And I'm talking about herd immunity, which I project would require between 70 and 85% of the population being vaccinated. And there's an interesting question, Vicki, that people ask, well, if I get vaccinated, why do I need to wear a mask? Well, the primary endpoints for both of the mRNA have been clinically recognizable disease, which is where you get the 94 to 95% efficacy. What we don't know yet, and we will find out sometime, but we don't know it now, whether, although you protect against clinically recognizable disease, do you protect against asymptomatic infection? So it is conceivable that a vaccinee could have been protected from being ill, but still has replicating virus in their nasopharynx. That being the case, it's important to continue to follow the mitigation of health, of the kinds of public health measures, because the one thing you don't want to do is be protected yourself, but yet spread it to someone else, which is a very good reason to be wearing a mask.
So Tony, can I just follow up on that question and ask you, do you think we're yet in a position to set what the thresholds will be? How many people do we need to vaccinate in the country before we can start to say the public health measures can be relaxed a little bit? I mean, this concept of herd immunity has been raised many times, sometimes controversially, but nonetheless, one of the goals of vaccination is to achieve sufficient amount of people who are immune to the disease. So at what point do you think we can, if not declare success, declare we're on the right track?
You know, let me start off, Bill. As you well know, anything one says in this can be taken out of context, and that's happened more than once with all of us, including myself, over the last year. We don't know, but we do know that if you get to about 70 to 85% of the population, if you make extrapolations from what the herd immunity level would be for measles, which is the gold standard, we all know that the more transmissible a virus, the greater percentage of the population you need to be vaccinated to get herd immunity. And that's the reason why with measles, which is 98% effective vaccine, but it is one of the most, if not the most transmissible virus that we know of, that when you get below 90% and get into the 80 percentages, then you start to see breakthroughs, the way we saw with the Orthodox Jewish population in New York who didn't vaccinate and got down into the 80s. So that's the reason why we say herd immunity for measles is about 90+%. Since COVID-19 or SARS-CoV-2 is a little bit less transmissible than measles and the vaccine is a little bit less effective, we've made a reasonable guesstimate that you need about 70 to 85% to get herd immunity. But your question is, I'm not talking about complete herd immunity. I'm talking about one of the things going to get a little bit better. You know, Bill, I don't know. I would imagine it's probably going to be half of that. I think as we get into April, if we get, 100 million people vaccinated in 100 days, the way President-elect Biden wants to do, I think you'll start to see some impact on the dynamics of the outbreak, which maybe would allow us to sort of pull back a little bit, but I don't think we're going to have to be able to pull back completely until we get herd immunity.
Great, thanks. So how do you think the US public health infrastructure should change to better prepare us to address not only this pandemic, but future pandemics and public health challenges?
Yeah, what we have done, unfortunately, and this is another example of what's the victim of our successes, that back during the time when we had TB in almost every community, sexually transmitted diseases in clinics, we had a public health infrastructure at the local level that was very sound, that was experienced and well-funded. Then we started to pull back on that because we were so successful with vaccines, with the availability of antibiotics and antivirals. So right now, what we need to do is try and get back to a local public health capability that is able to respond to any outbreak. Because if you have something centrally that's good, it's not going to work unless it's able to be implemented at the local level. So the thing we need to do is to rebuild up our local public health capabilities, which unfortunately has not been supported as much as it should have been over the last several decades.
And what can we do to encourage people to go into public health careers?
Well, I mean, I think that anyone who has any interest in medicine, science, and public health is to just look at what is going on right now. I mean, we don't like suffering, we don't like disease, we don't like deaths, but if you really want to get into the action, take a look at what's gone on over the last couple of decades. I mean, we've had pandemic flu, we've had Zika, we've had Ebola, now we got COVID-19, there's the ever-present HIV. I mean, you've got to go with what suits you. We all know that. And that's the reason why we chose what we're doing now in medicine. But if it suits you, I cannot imagine a more exciting thing for a young person to get involved in is in something that relates to public and global health, because the impact that you can have on society is enormous. So just take a look at the impact you can have, and I think it speaks for itself.
Agree.
So Tony, as we both know, the basic investment by the NIH in the science that leading to our understanding of HIV had many impacts beyond HIV. As you look at what's being done now scientifically in COVID, in terms of the basic investigation in its in the immunopathogenesis, in the virology, and the vaccinology, what excites you most, and what do you think has the greatest potential for moving beyond just COVID?
Well, the one that's the most obvious that everybody's getting ready to jump on, there was a lot of skepticism. We know of the advantages of the flexibility of the mRNA technology. Right now, the fact that it's been such a resounding success, Bill, is going to be, I think, applied to many of the non-yet vaccine preventable diseases that we've been working with, including HIV and malaria and tuberculosis, and the things that have really been stumbling blocks for us in the vaccine world. I believe that the jumpstart that we've seen now with these two highly, highly successful vaccines is going to spill over immediately into other areas. The other one is the use of monoclonal antibodies as a direct antiviral. We had success, you might recall, with Ebola, both with the Regeneron product as well as monoclonal antibody 114 from the Vaccine Research Center that was very effective in Ebola. We're starting to see positive results now with the COVID-19. In fact, the results would likely be even better if we logistically were able to give the monoclonal antibody earlier as opposed to hospitalization, which, because of the intravenous nature of the application, people have to be in a facility where you can do that. So I think those are two things that are going to be very important. The other thing that is still a mystery, and even after we get this under control, for those who are interested in the interface between infectious disease and inflammation and immune response, to study why people, even after virus appears to be controlled, an aberrant inflammatory response is what's killing people. We need to understand that better. So as we dissect out the pathogenesis of advanced COVID-19 disease, I think we're going to learn an awful lot about the interface between aberrant inflammation and pathogenesis.
So Dr. Fauci, we've been incredibly impressed with your leadership over the past year. And it seems like you've been juggling 5, at least, full-time jobs. So tell us a little bit about how you balance your COVID era duties with your other full-time jobs.
Well, it has not been easy. And what has happened, and I don't want anybody to feel sorry for me about this, but I have not had a day off since the middle of January of 2020. And that includes every Saturday and every Sunday. And, the days are 5 a.m. when I get up until midnight when I go to bed. And if you put that amount of time in, you can actually do both. I've made a very very, very important commitment that I would not neglect my job as director of NIAID with all of the other responsibilities we have to HIV, to malaria, tuberculosis, other types of not only infectious, but inflammatory and immune-mediated diseases. At the same time, that out of necessity, not only I, but so many of my colleagues have had to pay so much attention to the response to COVID-19. And I think as scientists, all of us in the scientific community should really feel good about, if there was one resounding success in all of this, it has been at the level of the science. And it isn't only what we've done here at NIH and Bethesda, but the countless number of grantees and contractors whose fundamental basic science led to the kinds of things that we were able to do so quickly. So I think that this is really an important accomplishment of the entire scientific community. But the answer to your question is, Well, when I talk to non-medical people, Vicky, it's really something I say that they may not understand, but you all will understand it. You know, back when I was an intern, assistant resident, and chief resident, it was at a time when you were on every other night and every other weekend, which there were some good things about that and some bad things about that. But you really learned back then how to suck it up. You know, you have 3 patients who are sick as can be, and the ER calls you up and says, by the way, I have a bleeder coming up, or I have somebody who just had an acute myocardial infarction and arrested in the ER. He's coming up. You don't say to yourself, excuse me, I'm too busy. You say, okay, bring him up. So it's the same thing now. When you're dealing with a crisis like this, just make out you're an intern again and do it.
Thank you.
You may not hear it, Tony, but you're getting some applause from our residents behind me. As you know, there's been a lot of anxiety in the infectious disease community about careers and career structure. We haven't had the level of interest in infectious disease training, and it's been a big issue for the infectious disease societies. As I'm putting you on the spot as your role as director of the National Institute of Allergy and Infectious Diseases, what can we do to really encourage people who want to become physician scientists, not just practitioners in infectious diseases, but physician scientists, and particularly physician scientists in infectious diseases?
Well, I think what's happening now is certainly generating the interest. There are many, many more people who now are seeing what an impact one can have, not only in clinical infectious diseases, but in the scientific aspects of that, Bill. And what we are doing now, and we started this a couple of years ago, is to try and increase the amount of resources we're putting into training to give people the opportunity. The other thing that we're doing, and we obviously resources have been constrained, but we've made it a priority, is to try and develop programs where investigators can gain independence earlier, in the sense of getting them a good mentor, but then making sure they don't stay in a situation that it's 42 years old before they get their first R01. Namely, to be able to get them much earlier in their career, which is a time when they likely would be more productive. And we've made a commitment that over the next couple of years, we are going to make that a high priority.
I think we have time for maybe one quick question. I think one of our major challenges still is overcoming vaccine hesitancy and the getting people to comply with basic public health recommendations, which fall down on human behavior ultimately. So we have great science and vaccines, but we can't always get people to participate. So what do you think we should be doing to reduce vaccine hesitancy and improve adherence?
Well, I think we've got to be extremely careful in our messaging. We've got to, first of all, not criticize people who have hesitancy, but reach out and say, we understand why you might be hesitant, but let's take a look at the scientific facts and take the time to explain in clear language, not talking down to people, but not talking in the way that's so arcane that they can't understand what you're talking about, and explain to them the risk benefit and pick out the 2 or 3 things that they're concerned about and explain. We do that with the vaccine for COVID-19. People say, well, you've gone too quickly. There must be something wrong there. You must have cut corners. And then you explain, no. As a matter of fact, the speed is related to the breathtaking advances in the science of vaccine platform technology. And safety has not been compromised, nor is scientific integrity, and explain why. And then people say, well, is it really safe and effective? And then explain to them things they don't understand, that the decisions that are made about safety and efficacy go right through a data and safety monitoring board that is completely independent of the government and completely independent of the pharmaceutical company. I just think we need to take the time to explain in clear language that there is a scientific basis for when we say something is safe and effective.
Thank you.
So, Tony, we can't finish without having me ask you a question that Jerry Madoff would have asked you. As you probably know, Jerry never forgave the Dodgers for leaving Brooklyn. And so I think question he would have asked you is, what do you think of the designated hitter?
You know, I've never liked the designated hitter at all. In fact, I think that's one of the real mistakes in baseball. I don't know how Jerry felt about it, but I didn't like it.
Jerry was a National Leaguer for all his life.
Right.
So, Dr. Fauci, I want to thank you. Really, this has been an incredible opportunity. It's a wonderful testimony to Dr. Madoff, but also to your career. You've been an incredible inspiration to all of us throughout the year. I think whenever any of us felt like we were going to lose it or pull our hair out, we often thought back to what Dr. Fauci would do and how you stay so calm despite all of the challenges and continue to be forward-thinking, data-driven, and really pushing the science to protect the public. So I personally want to thank you for all of your leadership, your incredible energy. I hope you can take a day off. We need you to stay healthy, well, and resilient. So your personal wellness is very important to all of us. So please, maybe I should call your wife to make sure that she gets you to take some time off. But thank you very much for your time this morning. We're very grateful.
Thank you. Thank you, Vicki. It's really a pleasure to be with you. Thank you, Bill, for giving me the opportunity to join you today, particularly to pay honor and respect to a great person in medicine, Jerry Madoff.
Well, thank you very much. I know you have about 18 more appointments in the next 6 hours, so we'll let you get on to your next meeting.
All right. Thanks again. Take care.
Very much.
Bye-bye.
Bye-bye.